This is a video to help you with these questions on Dalton's atomic theory. So let's start off. Okay, so we've got to complete the following sentences, choose from these words. Okay, so we've got some sentences here, we've got to fill in the gaps. So this first one, the ancient Greeks believed that everything was made up of very tiny something called something, and that they were all the same. Okay, so the important bit, and you should remember this, the Greeks believed that you could just sit around, if you were clever and you took your time and you were careful, you could just sit around and have discussions and you'd be able to work out the answers to basically everything. Okay, and that's how they came up with an idea that if you cut something up into smaller and smaller pieces, you'd eventually get to a piece that you couldn't cut any smaller, and they called those atoms. Okay, and they were very tiny particles. Okay, and particle just means a small bit, so very tiny particles called atoms. Okay, so that one everyone should remember. Now this next bit, this is all about the scientist John Dalton, and as chemistry got to know more and more about materials, they began to realize that the materials were not the same. They were not made out of the same bits and pieces. Okay, so Dalton came up with a new theory based on evidence from experiments. Now this is something that the old philosophers, they didn't do. Okay, they just sat around and talked about things. Okay, evidence from experiments and calculations. Okay, so they made experiments and they got calculations. Dalton now believed that not all atoms were the same, but it depended on the type of matter they were made from. Okay, right, so in this next bit, it starts off by giving you some information about Dalton's ideas. So here's the first one. Atoms cannot be broken down into anything simpler. Okay, all of the atoms of an element are the same. So that would mean they're the same size, they're the same weight, and they do the same things. Okay, when two or more different types of atoms join together, a compound is formed. So that's what a compound is. Okay, you've got two or more different types of atoms joined together. Okay, that's another important point. And then during a chemical reaction, atoms are rearranged. Now it's important, that one, they're rearranged. Okay, and what that means is that there are no new atoms being brought in. Okay, the atoms that you start with is the same as the atoms that you end up with. All that changes is the way that they are arranged together, the way that they are fitted together. Right, quite important. And we'll need to use these bits of information to help us with the next couple of questions. So here's the first one, and it says circle two compounds, and the circle is quite important. You really do have to put a circle around things. You can't just tick it or underline it, something like that. Okay, so let's start with this one here, H2. Now what you're looking at there, this is it drawn out in letters, and so another way of looking at it would be like this. It's H and then H. Okay, there we go, there's number one, there's number two, H2. Now is that a compound? Okay, is this a compound? Well, it says up here compound is two or more, so 2, 3, 4, 5, 6. Right, but what we've got here is one. There's only one type of atom. Okay, so this one is not a compound. Have a look at this one over here. How many types of atoms have we got? Well, we've got one, and they're both the same. Okay, remember, a compound is two or more different types of atoms joined together. Okay, so this is only one type. This is not a compound. Let's have a look at this one, CO2. Well, if we draw this out, Okay, we've got a carbon, we've got a C, and we've got an O, and we've got an O, and they're joined together, something like that. This is one type of atom, and this is another type of atom. We've got two types of atoms. So this one, we can say this is a compound. Okay, so we'll put a circle around the CO2. This one over here, again, remember the definition. It's two or more different types of atoms. There's one type, okay, there's a different type. We've definitely got two types, and they're joined together. So this one also is a compound. Now for this next one, it's important that you know the meaning of this word, element. Okay, now an element is the simplest chemicals. Right? Elements are the simplest chemicals. They're not made of anything else. So, how many types of atom have we got in this box? Well, it's two. There's this white one and the grey one, and they're joined together. So this is a compound. Okay, that's a compound. This one over here, whatever this material is, it's made out of two different types of atom mixed together. Now they're not joined together, so this is not a compound, but this is a mixture. Okay, it's not an element. This one is a mixture. This one over here, we've only got one type of atom in there, so this one is the one that's an element. Now on to the next question. And what you're asked to do here, first of all, we'll read this. According to Dalton's theory, when an atom of hydrogen reacts with an atom of fluorine, a hydrogen fluoride molecule is formed. Complete the particle equation. Well, you've already seen these circles being added together. So what we're going to do here is we're going to say that one, let's just pretend that that one is the hydrogen and that one is the fluorine. Okay, and when they come together, what they're going to get is you're going to get those two, but they're going to be joined together. So here's my fluorine and here's my hydrogen. Okay, and you can colour this one in. Hopefully you do a better job than me. Okay, so that's the particle equation. So those two are now joined. Okay, they're now a compound. Now for that, it's a 2-mark question. You get 1 mark. Okay, so describe what happens to the atoms during the reaction. Well, all that you really need to say about this is that they are now joined together. Okay, and another way of saying that is that the atoms have become a compound. So over here they're separate, they're atoms. Over here they're joined together, so they're now a compound. Now if you use words like compound, okay, these are the scientific words. When your papers are getting marked, if you're using these kind of words, you are more likely to get the marks. It's easier for you to explain something using scientific words. Okay. Right, now this is quite a puzzle question, this one, and what it does is it shows you the symbols that Dalton used for his elements and some of the compounds that you might commonly find in chemistry. And what you've got to do here is you've got to use this code to work out which these molecules are. So let's start off. Okay, so the first one here, hydrogen, circle with a dot. Let's go through. Okay, so that's hydrogen there. Okay, so that's H, that's H. Let's see, there's another one. There's H, there's H. Right, okay, so we've done hydrogen. Oxygen is the empty circle. So that one is O, that one is O. This one is O. Done that one. Right, carbon is the grey circle. So there's C there, and there are no other carbons in there. Okay, sulfur is a cross in a circle. So this one is S here. Any others? No, that's it. That's sulfur. And this one, a single vertical line, that is nitrogen. Okay, so that one is there. Okay, so let's do matching up which symbol is which compound. Well, let's start off with something simple. Water. Oh, and I missed one out there. Okay, there's another oxygen. Okay, so water, H2O. There we go. There's one H2H. That's H2O. This one is water. So this one we can do straight away. Let's do another one, carbon dioxide. Now that is CO2. Okay, so there is a C and O, two O's. So that one is CO2. Let's see, another one, hydrogen sulfide. Okay, hydrogen sulfide is hydrogen and sulfur, which is this one. And that only leaves us with one, which is nitrogen oxide, N and O, nitrogen and oxygen. Okay, which is this one here. Okay, now just as a little tip, when you're drawing these lines, make them as straight as possible. If you've got a ruler, straight edge, use that. It will help greatly. And on to the last question. So here's some information. The word equation shows the reaction between 2.4 grams of magnesium and 8 grams of copper oxide. Okay, so here's the reaction. Your magnesium and copper oxide, when they're reacted together, what you will get is magnesium oxide and copper. Okay, so first question, what happens to the atoms during the reaction? Well, what it looks like here is you start off with magnesium and copper, and the copper is joined to the oxygen, copper and oxygen. Now over here, magnesium is joined to the oxygen, and you've got copper. So it looks here as if magnesium and copper, they swap places, okay? Because here the oxide has got magnesium, but at the start the oxide has got copper. So it looks as if either you could say that the oxygen goes from the copper to the magnesium, or you could say that the magnesium joins onto the oxide and gets rid of the copper. Does not really matter, but what you're talking about is the atoms get rearranged. Okay, so first thing that you would say is that they are rearranged. So the atoms have been rearranged. Yep, and for that you get one of these two marks. Okay, one mark there. And the second thing that you can say is that copper has been replaced by magnesium. Okay, or you could say copper metal has been formed. Either of those will do. And there it is, copper metal has been formed. The other thing that has been formed is magnesium oxide. So if you said that, that is also a good answer, and that will get one of the other of the two marks. Okay, now this final question, it looks terrible. It isn't really that bad. You've just got to go carefully through it. So it says, during the reaction, 4 grams of magnesium oxide was produced. Calculate the mass of copper. Show your working. Okay, well, let's go back up here. Here's the equation. This tells you exactly what happens. And it tells you here, you start off with 2.4 grams of magnesium. Okay, so let's just put it in there, 2.4. Okay, and 8 grams of copper oxide. Okay, plus 8. Okay, now you'd remember earlier on we said when there's a reaction, all that happens is this stuff gets rearranged. You don't have any more coming in. Okay, and what that means is all the material that you've got on this side is the same amount of material as what you've got on this side. It's just that it's been rearranged. Okay, now down here it says that in the reaction we get 4 grams of magnesium oxide. Okay, so let's put that up here. Okay, we get 4. Now, like an equation in maths, this is the bit that we don't know. Okay, this is the bit that we don't know. So we can put this as a question mark. Okay, so now we can do this bit. We can show your working. Okay, so 2.4 plus 8. Okay, 2.4 plus 8 will give you 4 plus something. Okay, 4 plus something. Okay, so we can rewrite this, because 2.4 plus 8, okay, that's 10.4. So we can say 10.4 will give you 4 plus something. Now, from your maths, you're probably able to remember that means we can say 10.4 take away 4 will give you whatever the something is. And if you take away 4 from 10.4, that will give you 6.4. Okay, so you can now say that your question mark, your unknown, is 6.4, and then you can say the copper, the mass of copper, is 6.4 grams. Okay, and for all of that you will get the 2 marks.